So I'm going to start off explaining what you need to figure out the sine, cosine, tangent of the angles I gave you today, the square and an equilateral triangle. Let's start with the square. If you draw the diagonal of a square, you're creating a right triangle, right? Because a square has four 90-degree angles, every side is equal. You're creating a right triangle with 45-degree angles in each corner. All right, 45-degree angles. If every corner is 90 degrees and you're drawing a diagonal, you're splitting those corners in half, so those are your 45-degree angles. So I'm just going to erase the rest of the square here, and that's going to be my 45, 45, 90 triangle. Now, use Pythagorean Theorem. These two sides are going to be the same, so let's just go with 1, because we always start off with like a base, kind of like the unit circle. Radius is 1, it's just easier to work with. So let's say every side was 1 in this. What would the side of the hypotenuse be? Well, it would be 1 squared plus 1 squared, which is just 1 plus 1 is 2, and then take the square root of 2, and you get the square root of 2 for your hypotenuse. So that's your 45, 45, 90 triangle, 1, 1 square root of 2. And now 30, 60, 90 triangle comes from an equilateral triangle. So again, let's start off with 1. Every side on our equilateral, well, it's actually easier if we do 2 on this one. So let's say 2. Every side of our equilateral triangle has a length of 2. Now imagine trying to find the height of this triangle. Say you wanted to find the area, you'd have to draw the height. Now the height is going to split this triangle exactly in half. And this half of the triangle over here, the bottom, the base of it, is going to be 1, just like it would be over here, because 1 plus 1 is 2. Now we're only going to deal with half this triangle, just like we did half the square to make a right triangle. And we're going to use Pythagorean Theorem to figure out our missing side. We've got 2 squared, and we've got a 2 and a 1. So we got to square 2, and we have to square 1, and we get 2 squared is equal to 4. 1 squared is equal to 1, and we're trying to figure out this side here. It's not going to be the square root of 5. We're not adding these. We're trying to find a leg. We're trying to find a straight side. So we're going to subtract and get 3, and then take the square root of that. So this is the square root of 3. All right, remember, this was an equilateral triangle, and in an equilateral triangle, every angle is 60 degrees. So this was a 60-degree angle, and we split this one in half. Just like the square started off as 90s, we split them in half, we got 45s. Well, this angle up here was a 60-degree angle before we split our triangle in half, so now it's a 30-degree angle. All right, so this is a 30, 60, 90 triangle. It comes from splitting an equilateral triangle in half. And that one up there is a 45, 45, 90 triangle, and it comes from splitting a square in half. All right, why am I showing you this? Because 45 goes into 360 evenly, so does 30, and so does 60. So there's a lot of angles on our unit circle that are going to be multiples of these 3 numbers. There are also going to be a lot that are multiples of 90, which I showed you yesterday. So you're going to have a lot of angles that you're going to be able to figure out the sine, cosine, tangent from without a calculator if it's a multiple of 30, 45, 60, or 90. All right, so for example, let's say we want to know the sine of 45 degrees. The sine of 45 degrees without a calculator. Well, you'd come to your 45, 45, 90 triangle, and here's a 45-degree angle. The side opposite of it is 1, and the hypotenuse is square root of 2, so it's 1 over square root of 2. And for now, that's good enough for your answer. 1 over square root of 2. Technically, the sine 45 is equal to square root of 2 over 2. And that's just because you can't have a square root in the denominator, so you multiply it by square root 2 over square root 2, and that's what you get. But I raced right through that explanation because it's a little bit tricky, and that's a different lesson. I don't really want to get into that today. So let's just for now leave it as 1 over square root of 2, just simple opposite over hypotenuse without simplifying our fraction. All right, how about down here? So we want to do a cosine of 30 degrees. Well, you go to your 30, 60, 90 triangle. Here's our 30-degree angle up here. Cosine is adjacent over hypotenuse. So that would be square root of 3 over 2 is cosine of 30 degrees. Square root 3 over 2. So you could pick sine, cosine, tangent of 30, 60, or 45 and figure this out pretty easily from here. And that's basically what the problems are today, except I've got some in there that are more than 90 degrees. So when they're more than 90 degrees, you kind of got to go back to this unit circle that I was using in the other video from today. So let's say you want to find sine of 150 degrees. How would you find sine of 150 degrees? Well, 150 degrees would be all the way over to right about here. So remember, there's 180 degrees in a straight line. If that was 150 of it got you there, the rest of it is 30. So this is a 30-degree angle. Now we're right back to our 30, 60, 90 triangle. Cross from 30 is 1. The hypotenuse was 2. Square root of 3 for your adjacent side. So what is the sine of 150? It's 1/2. So sine of 50 is 1/2, but the tricky part is actually that's just 1/2. It's not, I thought maybe it was going to be negative for a second, but it's not, because your one direction is going up. So it's positive, and your hypotenuse is always positive in this circle. So it's 1/2. Just like it would be if you tried to find the sine of 30 degrees. If you try and find the sine of 30 degrees, the opposite side over the hypotenuse is 1/2, 1/2. So when you get angles that are bigger than 90 degrees, check and see if they're multiples of 45, 30, or 60, and reduce them down to one of these two triangles. So that's a really good way to figure out sine, cosine, tangent of angles that are bigger than 90. More times than not, they're going to be multiples of one of these three numbers, 45, 30, or 60, and then the sine, cosine, tangents are going to be the same. So like if you had 225, sine of 225. Well, that just sounds crazy, but 225 is actually a multiple of 45. All right, 45 goes into 225 evenly. You go back to your circle, 225, well, 180 is right here, and then you got to go 45 more degrees to get to 225. So 225 is right there. That makes a 45-degree angle. So sine of 225 is the same thing as the sine of 45, because you're dealing with a 45-degree triangle right there. The only difference now is the side opposite of 45 is this length right here, and that was going down. So that's actually a negative number. So that makes this negative in this one, because it's actually going down when you get to 225. So it'd be negative 1 over square root of 2, as opposed to positive 1 over square root of 2 when we did the sine of 45 was positive 1 over 2, because 45 is just right here, and your side opposite of your angle, 45 degrees, is going up. So it's a positive 1, whereas here it's going down, so it's a negative 1. So 225 is negative 1 over square root of 2, and 45 is positive 1 over square root of 2. So the numbers don't change, just you got to be careful of your signs, your positives and your negatives. So hopefully that's enough information where you'll have a fighting chance for the problems for today.